All right, so it's just a normal polynomial. That looks really ugly and intimidating. So it could be 4x to the third minus 3x squared plus 2x minus 6. That's just what this definition says, okay? That you've got all of your terms in order, descending order, so biggest exponent first all the way down, okay? Could you have a polynomial without the 4x to the third? Is that still a polynomial? Yeah. Okay. So there's all kinds of different types of polynomials. So we're going to talk about those polynomials. Okay. Now, this number right here, a sub n, that is what we call the leading coefficient. And that is going to be extremely important in some of the stuff that we do the rest of the week. Notice that the leading coefficient goes with the first term, but that only holds true if your terms are in order, okay? So hypothetically, if it had been negative 3x squared with the plus 4x to the third behind it, that's not the leading coefficient because that's not the term with the biggest exponent, okay? So you have to put the terms in order first before you identify the leading coefficient, okay? So what we're going to do here is we're going to talk about the degree. And the degree, if you remember, apparently the weather has my computer not wanting to cooperate with me. Big shock, I know, because you know how much I love computers. All right, so we're going to classify each polynomial by its degree and its leading coefficient because this is kind of lead us into some other stuff. Now, the degree is the exponent. You have to have an exponent or you have to have a variable in order to have a degree. So this first example, this is the function itself, 4. Do you see a variable? Nope, no variable. So 0 degrees, and the leading coefficient is just 4. Okay, in the second one, I see an x with an exponent of 1, so the degree is 1. The leading coefficient is attached to that term that I pulled that exponent from. Okay, so what's the degree of the third problem? What's the biggest exponent you see? Okay, what number, what's the leading coefficient attached to that term? 12. Here, my biggest exponent is a 3, so that's my degree. My leading coefficient is the -1 that's out in front of that term. Okay, so I want you to fill in the last 4 boxes. All right, so in this one, what's the degree? And the leading number? All right, what are my last 2 answers? 5 and 9. Notice that every single one of these were in descending order. Every single polynomial was in descending order. Biggest exponent counting down all the way to the no exponent, no variable term. Okay, now some of the functions that we have dealt with before, and a couple of them we haven't dealt with yet, but we're going to. The constant function is the equation f of x equals to c. And c is just a number, any number. No variable, just a number. Okay, this will always give you a horizontal line, and we have talked about horizontal lines in this class. So this could be the graph of f of x equals to c. Since it's below the x-axis, I would assume that the c value would be negative. If it's a horizontal line above, the c value would be positive. But anytime you have a graph, let's say that this is f of x equals to, we'll just call it -2. Then this would be, there's -1, there's -2. That is the graph of f of x equals -2, straight up horizontal line. Then you have your linear. We've done linear. F of x equals to x. Now, very specifically, this is f of x equals to x. This is what they call the identity line. What you would see it as is y equals to x. That's what you're familiar with. Now, this particular line goes straight through the middle of first and third. That's what your identity line looks like. If you literally have this equation, y equals 1x, that's exactly what your line is going to do. If you change that, if you were to say y equals 2x, it would still look like this, but it would be tilted a little bit differently. So once you make changes to these graphs, they kind of change a little bit. Quadratics, we are familiar with that. In order for it to be a quadratic, it has to have an x square in it. Can it have the bx and the c? Absolutely. But the key value of a quadratic is the fact that it has x squared, and that's the biggest exponent. And we know that parabolas either open up or down, and they can be located anywhere on the coordinate plane. Now, a cubic function. Notice that all of these have infinity arrows on each end of their graphs. Infinity arrow, here, here. I've got 2 infinity arrows here. A cubic graph is an x cube, meaning if the largest degree or exponent you have is an x cube. Now, typically an x cube graph looks like this. That's what an x cube graph looks like. Okay. Now, I want you to pay attention to the fact this is even and this is odd. Do y'all agree? Notice that with this even problem, both of my infinity arrows are pointing the same way. What happens to that graph if I put a negative number in front of it? It flips. So both endings that are now going up, both endings would go down. They would still be going the same direction, but they would go down. Same thing here. If you notice x to the third, the ends are going in opposite directions. 3 is an odd exponent or an odd degree, so they go in opposite directions. What's the degree of this one? It's a degree of 1. Opposite directions. Okay? The shapes change. Once you start making those exponents bigger, every time it goes up an exponent, the shape changes a little bit. Now, when you get into the quartic functions, that means that you have a polynomial and the biggest term is an x to the 4th. The biggest exponent is a 4. Now, this looks very similar to the quadratic. The only difference is it's a lot flatter at the bottom than most quadratics are. It looks like a quadratic, but it's a lot flatter on the bottom. Notice my exponent is even. My endings, my infinity arrows are going the same way. Y'all have this page? Okay. And then we move up to x to the 5th. Now, I am getting bigger. This graph looks very similar to x to the 3rd, but it is a little bit flatter before it does the curves. So it's a little bit flatter in the middle, just kind of like this one is. But notice I have an odd power, x to the 5th, 5 is odd, and my endings go opposite directions. That will happen every single time. If your exponent is even, they go the same way. If your exponent is odd, they go opposite directions. Okay? Now, we're not going to use our graphing calculator. We are going to come back to these questions in just a moment. Okay? We actually need to fill out the bottom part, and then we can go back up to the top part. So, if you have an even degree, x squared, x to the fourth, x to the sixth, so on and so forth, if your biggest exponent is even, if you have a positive leading number, meaning positive x squared, positive x to the fourth, positive x to the sixth, both of your ends go up. If you have negative x squared, negative x to the fourth, negative x to the sixth, so on and so forth, negative x to the 10th. It could be negative 5x to the 10th. If the number in front is negative, that number can be anything, but if it's negative, both ends will go down every single time. Now, if you have an odd degree, positive odds, x to the third, x to the fifth, x to the seventh, so on and so forth, the endings go in opposite directions. Very specifically, if you're a positive x to the third, positive x to the fifth, positive x to the seventh, the left side will always go down and the right side will always go up. Now, if I throw a negative in front of any of those odd terms, these endings flip. The left will go up and then the right will go down. So, even degree has the infinity arrows pointing in the same direction. They either both point up if the leading number is positive, they both point down if it's negative. Odd, opposite directions, positive odd do this, negative odd do the exact opposite. Make sense? Okay, so graphically, I don't care about all the little waves and stuff. I've got two endings that are both pointing down. Would that be even degree or would that be an odd degree? Even. It would be specifically a negative even because they're both pointing down. All right. What about this one? It's odd. Now I'm going to ask the next question. Does that go with the positive odd pattern or does that go with the negative odd pattern? Positive odd. Okay. So now what we're going to do is we're going to backtrack up to those 6 questions that I skipped over. And we're basically going to do the same thing. Do you agree? We're not going to use a graphing calculator, but do you agree that this problem, this is the biggest exponent? Okay, that's a positive even. What do the ends of positive evens do? They both go up. Okay, now, this statement right here is asking what the right ending is doing. When x approaches positive infinity, if you're on the x-axis, isn't this positive infinity and that's negative infinity? Okay, so when they give you this statement, they want to know what the right ending is doing. Okay, this one's on the right-hand side. Is it pointing up or pointing down? It's going up, so it's going up to positive infinity. When they give you this statement, this asks what the left side is doing. This is your right side. This is your left side. This left side is also pointing up, so you are going towards infinity. In the second problem, negative x squared. What do negative evens do? The endings. They both go down. Okay, so we're looking at the right side first, the left side second. Be careful with this because in Math Excel, sometimes they switch that and they ask for x approaches negative infinity before they ask for positive infinity. Just remember, this statement always refers to the left arrow. This one refers to the one on the right. So my right first, that's pointing down towards negative infinity. Y'all agree with that? The left side, this is the right side, this is the left side. It's also pointing down to negative infinity. Now, these are called end behaviors. You are going to have some questions in your homework set that ask you what the end behavior does. And it will say the left goes up, the right goes up. Or it might just say up, up. Okay? But it's always reading the graph from left to right. Okay? Positive odds. What do the endings of a positive odd do? Odds go opposite, but which side goes down and which side goes up? Left goes down, right goes up. He said left went down, right went up. That's what he said. Okay? Remember, this is the right arrow, this is the left arrow. So when I look at that, the right side is pointing up, the left side is pointing down. All right? What do negative odd polynomials do? What do the end behaviors, those infinity arrows, do? Left goes up, right goes down. So remember, this is the right side, this is the left side. So right side this time goes to negative infinity because it's pointing down, and the left side goes to positive infinity. Now, if you were answering this question, you would actually choose up, down, because the first side goes up, the second side goes down. You always read the graph from left to right. Okay? Be careful with these because every now and then they flip them just to trick you to see if you're paying attention. Okay? I'm going to pause for just a minute and I'm going to let you fill in these blanks. Do we put positive or negative infinity? Where do they go? All right, y'all ready? All right, so I got negative infinity for number 5 because that's a negative even. It's negative, it's an even exponent with a negative number out in front, negative leading coefficient. So both ends point down. So the left and the right both go to negative infinity. Positive odd. My exponent is odd. The leading number is positive. So the left goes down and the right side goes up. So positive infinity for the right and negative infinity goes with the left. Make sense? Any questions about that? Now, I know you think I'm crazy for doing this, but this is going to help us when we start to graph. And I don't know if we graph. I do believe we do graph today. I was thinking we didn't graph until tomorrow. All right, so what we're going to do here is talk about turning points. We now know what the ends of these graphs are going to do. Okay, I know that a positive even, I know that both ends go up, but I don't know what happens. Does the graph do something funky like that? Does it just do like a normal parabola? What does it do in between those endings? Okay, so the point at which the polynomial switches directions, okay, turning points. Notice that I'm starting here and I'm going up, 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 and at that point I turn. So I'm going up here, but I start going downhill. Then at this point, I'm going downhill till I hit that spot, and then I'm going uphill again. Does that make sense? So I have two turns. When you change directions, you're going up till you hit that point, then you start going down. So you have two turning points. Okay? Now, if the turning point is higher than any other point, this is called the relative maximum. Such as this graph right here, this would be your relative maximum point. Because even though my infinity arrows go up forever, that's like the highest peak in the problem in between those arrows. Okay, if the turning point is lower than any nearby point, it is called the relative minimum. Now, I have two low peaks over here. Do y'all agree? This one's low and this one's low. But this one is lower than the other one. So this would be your relative minimum. Okay? Because I am going down, and when I hit this point, I start going back up. When you change directions, those are your turning points. And those turning points specifically have names if they are the highest point or the lowest point. Okay? Just another term, maximum and minimum values are called extrema. So if you run across that word, you know that it's just the maximum or the minimum value, the highest peak or the lowest peak. All right. Turning points define where your function increases and decreases. All right. You are increasing till you hit this point. You start decreasing. Then when you hit this turn, you start increasing. So you have an increasing interval here, a decreasing interval here, and then you have another increasing interval. Okay, so every time you change directions, it's going to give you that information, increasing and decreasing. Now, we are not going to do this section because we're not pulling out the calculators. I've already packed those up and pulled out the batteries. All right. Yeah. I changed my mind. Go grab your Chromebooks. Let's get our Chromebooks, and we will pull up a calculator so you can see. If you've got your own device, go ahead and pull that out. You don't have to use my Chromebook. All right, so once you get logged in, some of you may have used Desmos graphing calculator before. And I know it takes these computers a while to boot up and log in and all that good stuff. Now, when you are doing your homework, you should be able to pull up Desmos, and Desmos can help you with a lot of this, okay? Now, I'm going to have to move my, oops, that's not what I wanted. Okay, computer. Okay, so down in the very bottom right-hand corner, has everybody got Desmos pulled up before I keep going? Is it still pulling up? Okay. All right. Anybody still waiting for Desmos to come up? We're good? All right, so what I want you to do, since this is just the regular polynomial, you don't have to type in y equals or anything. You just type in the polynomial. So we're going to type in negative x, and then down at the bottom, you see a squared or a to the b power. Since we need a 3, I'm going to hit that button. And we'll scroll over and put plus 3x. And then, of course, there is an actual square, that a squared. You type that in. Now, are negative endings supposed to do what that graph does? Negative odds. Are the endings on this graph doing exactly what it's supposed to do? Okay. So that's always a good thing to check. One of these days, y'all are going to be walking outside and my tablet is going to go flying out the window and just drop in front of me. All right, so negative odds, the endings are supposed to go left side up, right side down. So that's doing what it's supposed to do. Do y'all agree? All right, so this is your minimum point, and this would be your maximum point. All right, so all I have to do here is just press on that and just press on the graph with your mouse. So I know that's at 0, 0. Okay, I can come over here and go all the way up here, and I get to 2, 4. And you can just click on that point, and it marks it for you. So you know the minimum value is the y value, and the maximum value is the x value. Okay, so let me grab. So we're going to go ahead and fill in our minimum, our maximum, which was the 0.24. And the minimum was at 0, 0. And we need the right side of this graph. What's the right side doing? Is it going up or down? It's going down. So negative infinity. And then what's the left side doing? Going up to positive infinity. Now, you have infinity arrows on both ends. Do y'all agree? Okay. And they're going opposite directions. When you have those infinity arrows going in opposite direction, your domain and range will be all, hold on a second, real numbers. If your arrows go opposite directions every single time without fail. Okay, and we'll pick up with the increasing and decreasing when we finish lunch. So to calculate your increasing and decreasing interval, always start on the left-hand side, and you're going down until you get to this point. So this is what they call a decreasing interval, okay? You're starting at negative infinity and you are stopping at 0. This is always the x values. You're not going to use the y values. You're only going to use the x value. At this point, you turn and you start going up. So this is an increasing interval. This one increases from 0 to 2. You never use the y value, always the x values. So from here, we started at 0 and we increase to 2, and then we decrease. So we are going to decrease again from 2 to negative infinity, because this thing keeps going down towards a negative infinity. So let me pull up our documents so we can fill that stuff in. So our increasing interval, we had one from 2 to 4. I'm sorry, we did not. What was our increasing interval? 0 to 2. So let me erase that. I apologize. 0 to 2. And then we had 2 decreasing. We had an infinity to 0. And we're going to put that with 2 to negative infinity. We had 2 decreasing and 1 increasing. Now, if you want to rough sketch that graph on your graph paper, or you can just pull up Desmos if you need to again, that's fine. Okay. So you do not have to graph using a table. That's what Desmos is for. What I'm really wanting you to do is look at the graph and kind of interpret what's going on with the graph. Does that make sense? All right. Our next graph. Now, x to the 4th. If you have an even degree, your domain and range, actually your range is special. Your domain is still going to be all real numbers. If they asked for it in interval, that's what you would put. But our range is going to be different, because what do the ends of an x to the 4th, a positive x to the 4th graph do? Do they both go up? Do they both go down? Do they go opposite directions? What do positive x to the 4ths do? They both go up. So the left side goes up and the right side goes up. So this is right, this is left. So since they're both going up, which means I'm not really sure what happens here, but we're going to start at this point and go up. So your range is going to be a little bit different. It's your range that will change. This one does not. If you have 2 infinity arrows, the domain will be all real numbers. Okay, so go ahead and pull up your graph. And you can just clear that out and type that in again. Remember, you don't have to put the equal sign in because it will graph it without it. X to the 4th plus all right, that's what your graph should look like. If you want to sketch this on your paper, you can do that, but you always have access to Desmos. You can type it in and look at it again. Okay, notice that this is the lowest point. There is nothing below that point right there. Do y'all agree? Okay, so my range starts from that point and goes up. So what I'm going to do is I'm going to trace that until I get to that point. So I know what that point is. I know what that point is. I know what that point is. Those are my turning points. They're not pretty turning points. All right. Everybody okay with that? And that's okay. We can write down these numbers as well. All right. So my range, and you'll write this down on your other sheet of paper, your range starts at this point. The y value of that point negative 3.3, and it goes up from there. That's the lowest point. You always start with the smallest number if that's the lowest point, and then you go to infinity. Okay? Now, this is your minimum value, so write that ordered pair on the relative minimum blank. And this point, y'all can click on that. It should be 5, 0. That will be my relative maximum point. So this point right here, that is your maximum point, and that is the point 0.05. This point is lower than this point, so that's why this is the minimum and this is the maximum. So you should have your domain, which is all real numbers, your range. You have your maximum and your minimum value that we just wrote down. We've already done the end behaviors, correct? The left goes to infinity, the right side goes to infinity. Okay? The last thing that's left, we're going down, so we're decreasing. At this point, we turn and go up, so we're increasing. Well, we turn around and go down again, so we're decreasing, and then we have an increasing. So we have 2 decreasing intervals and 2 increasing intervals, and I think I wrote those backwards. So I'll do what's on your page first, which is increasing. So from this point, the x value, these use the x values only. Okay, so increasing, my first increasing starts at negative 1.8. You can put the 3.8 if you want to, and it stops at 0. My second one starts right here. Does anybody have that point? Because I didn't identify it before I froze my screen. 1.08. Is that? Okay. So 1.088 and then 3? 2.95. Okay, close enough. All right, so that would be from 0 to 1.088. You're doing the x values only. I don't need the y values for any of those. Now, decreasing starts from, on the left side, you're actually starting negative infinity to that negative 1.838. And we have another decreasing. Y'all let me do that. What should this one be? That's decreasing. Goodness gracious. I apologize. Ooh, wait, come back. That was a decreasing. My other increasing starts here and goes to here. I apologize for that. 1.088 all the way to infinity. All right. So the last one that we're going to do on this particular page is number 4. All right, so we said our range, what did we say our range was? Negative. Okay, say that one more time. To infinity? Okay, yep, that's right. All right, so our maximum, what was our maximum again? That I remember that one, 0, 5. What was our minimum? And then what was the other coordinate? This point? Okay. 31? Okay. Oh, wrong eraser. 31. And then our increasing intervals, because I totally messed those up just a minute ago. So we are increasing on 2 intervals. What was the first increasing? Okay. Is that increasing or did we change that? So negative 1.8 and 0. And then what was this one? Because this one should have been the infinity one. Back up. Oh, went too far. Increasing 1.8. Okay. 1.08. And then our decreasing was negative infinity to okay. All right. So the last one that I want us to do is number 4. I'm going to kind of let you go through all of this. Now, this is a positive odd, so you know the ends should do this. And I'm going to go ahead and help you. This is all real numbers. Anytime it's odd, I don't care if it's positive odd or negative odd, you have infinity arrows going in both direct or one up and one down. So that is your domain and your range every single time. It's the x to the 4th or x to the 6th or even x squared. So I'm going to give you a moment to go through and answer all these. You can use the computer, use the graphing feature. All right, so that's what I ended up getting based on those points that we marked. How do we do?